Okay, so this is a video of the lecture that we had when you were either absent or you went to the debate. One thing that I want to talk about is if you go to the website, just to clarify this before you go, you're going to go to right here, Unit Test Reviews. There's now only one folder. And you're going to go Unit 3, Blank Copy, or the Key. Okay? So when I click on one of these, you're going to find that vectors turned out to be a very, very easy unit. However, at the very end of this unit, there are some problems that right here, they're called polars. We are not going to cover this on the test. We will get to them at a later time, right before you start doing the BC stuff for next year, as far as the calculus stuff. So right now, I'm not going to test you over polars, but they will happen at a later date. They are very similar to vectors, but I want to close vectors up and continue going forward. Okay? So on the test review, don't worry about those polar questions. If you are just intrigued to know, you may look at the key that is right here, and all the answers are listed there in that regard. Okay? So for today's notes, what we're going to do is we're going to finalize bearings with direction and real-world free response or free body diagrams. Let's look at the first example. It says, from port a ship travels due east for 18 miles, and then it goes southeast for 12. So real quick, let me highlight the direction. From your quizzes, the thing that I would say for you to work on is making sure that you've identified the initial point and where the arrow is located. And when you have multiple vectors, doing another initial point, just like you see here, and you're going to end up drawing your vectors on the test. Okay? Just be very explicit as far as showing this direction and the initial starting point of each vector. Some people did this. They had this, and then they had another one, and then they had another one. So if, let's say, this vector right here is u, and they said, well, vector u was 3, 0. Okay? And I said, draw me a vector that is 3u. Well, they drew 3 arrows to show that it was a magnitude multiplied by 3. You do not have to draw 3 arrows. Just draw one, but you're going to show it with the length of 3 times whatever it was, which in this case would be 9, 0. Okay, so just to clarify that, when you get your quizzes back here in a bit after this lecture, you're going to see as far as what I was talking about in that regard and how you drew your vectors and whatnot. All right. So at this point, how far was the ship from port? So you're trying to find how far was this from port. Okay? So write down the navigational bearings for traveling east and southeast. So bearings, not directional angle, but bearings for east. Okay, we should know by now, north, south, east, and a SpongeBob would say west or west. So east is going to be 90 degrees. Bearings wise, east is 90 degrees.
Because it goes the opposite direction with the initial thing.
Yeah. Yeah. So southeast. Southeast is showing this. And again, bearing starts from 12 o'clock and it goes clockwise. Okay? So however far it takes, we know that it's going to be 90 degrees plus an additional what? 45 degrees. And that is implied when you're talking about southeast being right in between east and south. Okay? So the bearing for southeast, this is how you would do it on the test, is going to be 135 degrees. Now, we cannot solve vectors in bearings. It has to be in rectangular form because it's correlated to the Cartesian plane, to the XY graph and the unit circle as far as quadrant 1, 2, 3, and 4. Okay? So tell the trigonometric rotation angles, theta, for each of the heading. So for this first one, we're going to do it in a form of theta. Okay, just like it is as far as bearings is located, which is 90 degrees. That's bearings. What's the trigonometric rotational angle that is equal to? 0. So you're going to put 0 degrees. Yes, if you put 2 pi or if you put 360, it's still the same. But just put 0. And then the southeast,
That is a negative 45
Yeah.
degrees or
315. So you could do 315 or negative 35. Yes, they would both work. But now what I'm doing is I'm starting to put it in rectangular form, and rectangular form being this, so that I can start developing my chart, if you will. So let's go to C. C says describe the headings with a vector sum and then find the resultant. So vector sum, let's look at the first vector. Let's call the first vector A. Let's call the second vector B. So A is just looking at what it shows and developing some kind of vector component, which in this case is going to be 18, 0. Okay? So 18, 0 with vector notation, not points, is going to show the components of vector A. What's B?
cosine of 12.
So 12 almost, so you were on the track. Cosine of negative 45 times 12, right? And then the y value will be 12 times the cosine of, or not the cosine, but the what? The sine. Sine is y, cosine is x. And you have negative 45 degrees. Now, yeah.
Would it just be like 6 root 2 negative 6 root 2? Yes, correct.
Say again, what?
Yes, I mean, yeah, we did it.
Yeah, you could do that. So whenever you're doing the components, I would prefer you, if it does say write it in the exact form or the exact answer, yes, by all means do the square root. But if it doesn't, go ahead and do it to 3 decimal places as a standard. Okay? So what do you get anybody to 3 decimal places for vector B? 8.485, and then negative 8.485. Good. So whenever I'm asking you for answers on the test, I want you to write to 3 decimal places unless otherwise specified. And please be more careful with that, because some of you missed points because you would round to the nearest tenth when it asked for the nearest hundredth and so on and so forth on last test. Okay, so those are my vectors as far as independent components for vector A and B. Now we're going to explain how the resultant vector can be used to determine the ship's distance. Well, all I'm doing is adding the vectors, and I now know the distance, which is the magnitude of that last vector. So this is, again, is the resultant, and drawn correctly, the arrow would go here, and the initial point would go there because of either tail-to-tip method or parallelogram method. Okay? Now, adding these, how am I going to get the resultant? What do I do?
You just literally add them.
Yeah, I just literally add them. So add this and add that.
You get 26.485.
26.485. And then adding the other ones, what do I get?
Just repeat it because that's easier. So it's
So
negative.
Negative 8.485. This is my resultant. So let me go ahead and resultant. Otherwise, how do I write that in vector notation?
A plus
A plus B. And that's it. This is A plus B. That's it. Don't put the absolute value signs because I'm not asking you for the what?
the magnitude.
The magnitude. Okay? If I then want the magnitude, hold on just a bit. So what is the magnitude from here? These are the components. I do actually want it from here. I was looking at the next question. The resultant vector can be used to determine the ship's distance simply by finding the magnitude of what you see.
It's
This-
27.811.
27.811. So this is what I'll say right now. And you can verify her answer here in just a bit. When I am doing the magnitude, which is written like this, again, that is not the absolute value of A plus B. It is
The
A squared, or sorry, the
square root of x squared plus b
Yep. square root of x squared plus y squared. So you're going to have your x squared term, square it. You're going to have your y term, you're going to square it. Then you're going to take the square root of that sum. When you are doing that, I hope that you are putting the exact answers as you're doing that, or at least to 6 decimal places. Because again, you're only going to round at the very, very, very end. So when you do that, can someone verify that when you do this x squared and that y squared and you take the square root, can you verify that you do get 27.81? Okay, so 27.811 what? Magnitudes need units. Say again? Miles, yeah. So it's not always going to be meters per second or feet per second. It could also be a distance as well. It's the strength of it, the length or the strength. Any questions from what we are doing or what we've done so far?
So a plus b with like the absolute value around that edges is always going to be the notation for resultant.
Yes, this will always be resultant. This will always be the magnitude of the resultant. Okay? Okay, so now looking at this, part E, well, yeah, so I see what I did. I pretty much did D and E on one slide. The D part was this answer here, and then the E part, which is saying, at this point, describe how far was the ship from port. We kind of already did that already. Okay, so now let's go to another example. Now they get a little bit more difficult because of just the direction that you're traveling and whatnot. The thing that I will say for you to concentrate most on is identifying your initial point as the origin. So here's the initial point for that one, and here's the initial point for that one. So vector 1 is doing this, and it says from a port a ship travels at a bearing of 40 degrees for 30 miles. So again, you know bearing comes from north, and it goes clockwise. So I'm going to go until I create some kind of 40 degrees, and that's the way that I'm traveling. Okay? And then when you get there, you must face north again. So it's like you're facing north, you figure out what 40 is, but when you get there, I want you refacing north so that you know whenever it says a bearing of 140, you know how far that is. It will be 90 degrees plus the additional 50 degrees. You with me? Okay? So you always have to recalibrate, just like we did when we were outside doing the exercise drill. We recalibrated to where north was, or where our 3 o'clock was, so that we could find 0 in rectangular form. Okay? So at this point, how far is the ship from port? So this is what we're going to do. We're going to write down first the notation as far as bearings go. So in bearings, the first one is 40 degrees, which, what is that in rectangular form? 50 degrees. Because if this is 40, remember rectangular form, which is this form right here, starts from 90 degrees, or 0, on the x-axis, and that would be 50 degrees, the difference. Okay? The next bearing was 140 degrees. Otherwise, what would that rotational angle be?
Negative 30 degrees.
Not negative 30, but negative 50.
Sorry.
Negative 50 degrees. Because that is talking about from this 3 o'clock, this is negative 50 degrees. Okay? Now, part B says, write each. So this was my goal, is to get these things. Because that's the rectangular form. It says, write each heading as a standard position vector. So here we go. Let's label this one as A, this one as B. So vector A should be 30 cosine of 50 degrees. You don't need the degree symbol in there because what we've been doing is only degrees, not radians. And then 30 sine of 50. This will give me the numbers, which is approximately what, those of you handy with the calculator? 19.28 what?
4.
Okay, and then the other one? Anybody? 22.981. Thank you, guys. All right, our next component, again, remember when you're doing this, you must be in degree mode. B's components were the similar thing, cosine is x. However, we had a negative 50, and then we had a magnitude of 55. And it's 55 is the strength times the sine, because we're looking for the y. That's negative 50. And anyone handy with the calculator, what are those three decimals?
35.352.
35 what?
3.
Okay, and then?
Negative 42.132.
Thank you. Now, next part says find the vector sum. So all you're going to do is add those together. Okay? So you're going to add your x components together first, and then you would add your y components. And when you do that, you should be doing it to the exact or to at least 6 decimal places so that you're not off on the test. And you should get around 54.637 and negative 19.151. You agree? Okay. So at the point described, how far was the ship from port? So this is, what do we call this vector again? The resultant. How do we label it? A plus B. If we were graphing it, some of you missed this on the quiz, how would we label the resultant? We would label it as dashed. Don't do it solid. So this would be A plus B, this is B, and this is A. Okay? So at this point, how far? Well, part D is saying find the magnitude now. And the way we do it is x squared plus y squared, take the square root. And what do you get to 3 decimal places? Anybody?
57.896.
Yep. 896 miles. So yes, please put units on the magnitudes. Put degrees on angles of rotation, obviously. Or the rotational angles, that is. And then E says, if another ship leaves port to meet the original ship at this point, what bearings should we use? Now let me talk you through this one. First of all, we know that this is reflective of the length of that. So to know what bearings, I first need to know what? The angle. I need to know what angle is that green vector traveling at. And when I'm saying angle, I'm talking about in rectangular form. You remember how to do that?
Make a reference triangle from the components.
You can make a reference triangle or know that you're going to take the arc what? The arc tangent. Because you have x and y components, it will be the arc tangent of the y over x. You with me? Okay. So the arc tangent is going to be the arc tangent of negative 19.151 divided by 54.601.
I got negative 19.316. Yep, that's right. That's what I got.
Oh, am I rounding these? Or, oh, you're talking about the answer. Okay, my bad.
Oh, yeah.
Okay, I'm sorry. You get negative,
19.316.
thank you. And this is not in bearings. Right now, this is in rotational angles.
So you
this
make
is
that
in,
positive and add 90.
yeah, or whatever it is, I just want you to know that this is going to be right there. Okay? So I don't want you worrying about equations. I know that you can figure it out as far as how much it is, but don't worry about equations. Just know that how far is it from there? Yes?
Where'd you get for the bottom 54.601 if the x is 54.637?
I don't know why I wrote. It's 637, right?
Yeah.
Good question. There we go. So my x component is this one, 637. And we still get a 19.316 from that?
Yeah.
Okay, thank you. All right. Good. Participation points, I'll put them up here in just a bit. So with this in mind, all I need to know is, yes, this is a 19 absolute value-wise, 19 point whatever. So we're just going to add the absolute value of that, just make it positive, and then plus 90. Okay, what do y'all get? 109.316. And this is,
Don't you have to flip it
bearing.
Because if it's starting at the tip and traveling back to the origin, shouldn't it go the opposite way?
So it's not traveling back to the origin.
It's traveling from.
It's traveling from here this way. Because reading the problem, it said if I had another ship leave to meet it, that's what it would do. But we also didn't need that information because when we add vectors, tail to tip shows it will do this and then there, and the resultant means that it's just going to meet it there. Okay? Alright, so let's see. This is called bearing. So you would say at a bearing of, and then you would write your answer. Nicely
Could
done.
you do beta?
Yeah, you can
equals
do beta.
109?
Alright, so last two problems. And then we're done for the unit, okay?
Oh my god. Do we have a test next time I see you?
So on Wednesday, those of you who are absent, on Wednesday we will have bonus point participation. There will be a lot of individual stuff for that, so please come ready when you have the chairs up here. We'll have some group, but mostly individual. And then the next time we see each other, which I believe will be next Tuesday, that's the test. Okay, so here we go. The last part of this is the following. We've been going this direction. We figure this out. We figure this out. Our goal has been to figure these out because when I would add them, I would get the resultant. And then last but not least, from the resultant, I would go backwards to find these two.
But this is going backwards.
Yeah.
This is going.
This is going even further backwards. So we're not starting from two vectors, adding them up together and getting the resultant. We're having one vector, and we already know what resultant we want to occur, and we're just working backwards to make it occur. So instead of adding, we're going to be subtracting from the resultant, which is pretty straightforward, okay? So that's why you see this right here. Okay? So the resultant, we're going to know this, and we're either going to subtract this in order to get this, or we're going to subtract this in order to get the middle one. That's all it is. So let's go ahead and set up the equation or the chart. It says an airplane needs, and this is how you're going to know that it's going to be the subtraction, because you know what it needs to do. It needs to go east at 170 knots. Notice how it's labeled here. It shows the resultant as R. We could also show it as, if we wanted to, the wind plus the plane's magnitude. And a lot of you are going to end up doing that, and I hope that you would do that. Okay? So the resultant is the W plus P, but the absolute value sign showing you the magnitude is 170. So that goes here. The only thing that I would say to put on your test is units right here, just like we've been doing for the longest time. If you do this chart, which I hope 100% of you actually do, because it's an easy way to organize all your thoughts, these two will have units, these two columns, and this one does not have units. Okay, you're just going to write your 3 decimal places. Alright, so the components from the resultant is the very first thing that I should find, that I'll know that I need to find, but we're just going to keep going as far as trying to figure out what we're looking at. And the components, those of you who have already done this in your calculator, your x component for the resultant, so the components will be the magnitude times the cosine of the angle. Now, what's the angle that I'm traveling at? 0, because it's east. What if it said that it was traveling from the east? What would your directional angle be? It'd be 180, right? Because now you're traveling west. Okay, so be careful with that, from or to. Okay, so to be 170 times the cosine, and then 170 times the sine of what? 0. Those of you who have already done that, what are your components for your resultant? 170, 0. Okay? Reading on, it says, but fights a 25 knot wind coming from the north. And this right here, shown here with W. W for wind. You see, this is 25 knots. It's coming from the north, so it's going south. You could do this as 270, or you can do it as negative 90. When you do the components of that, you should get 0, negative 25. So now all you have to do is just subtract the resultant minus the one that you know, and the one that we know is the wind. And then you should finally get 170 minus 0 is 170, and then 0 minus that negative 25 is a positive 25, which makes sense because it would cancel if you were to add them and check. And then from here, you're going to work backwards to get your directional angle. So this directional angle, just like we've been doing, is the arctangent of the components y over x.
8.366.
So you get 8.366 degrees. And the magnitude was what?
0.828.
Good. Knots.
Knots.
Okay? Pretty straightforward, right? Not difficult. So your last example problem of the notes is this one right here. Now you can look at this like a field goal, if you will. Let's say that there was a field goal here and you're going to kick a ball. And I asked you, what angle would you kick it at, and with what strength would you kick it? This is similar to that kind of problem. Okay? So, and of course, your thing would be here. Okay? Just visually for you to see the kind of other problems that you could have. So if a golfer hits a drive, she wants the ball to travel straight ahead at 50 miles an hour. She needs, same thing. What vector did I just describe? Resultant. So the resultant here, we have the person and we have the wind. You could do A, B, or you could do whatever you want. They chose to show us S and W. W is for the wind. The resultant that we need is what?
We need straight ahead 90 degrees. With,
But what's the resultant?
0.50.
0.50. 0.50 is what we want to happen. So we're starting way down here. If you're using the chart. Okay? So this is S plus, S plus W. This is S and this is W. You with me? Then it says, however, she will have to compensate for a wind coming from her right side. What direction are you traveling, obviously? Left or west, or how many degrees? 180. So this is coming from her right side. This is 180 is the angle. So let's put wind at 180. What is the magnitude? 12 what? Miles per hour. What other information are we given? What is the magnitude of the resultant? Of the resultant. Are we given it? No, we need to find it, right? So, x squared plus y squared, take the square root, is 50 miles an hour.
Yeah.
So 50, I was just asking if we were given it.
Oh.
No, we have to solve for it, right?
Oh wait, no,
Aren't
R.
you giving it though?
Oh, my bad, I'm sorry.
Yes.
I'm sorry. Touche. Yes, I was given it. So
Okay.
50 miles an hour. So what direction, angle, so this is the magnitude, this is the angle, and these are the components. What directional angle was this resultant? 90 degrees. And yes, just like you've been doing with everything else, you're going to do the magnitude times the cosine of that to get your x component, the magnitude times the sine of that to get your y component, and what would you write down for the wind? Or you would already know because it's at obviously horizontal. You're going to have, those are easy whenever they're on the x or y axis. Cool? So subtracting this, what does your swing or kick have to be component-wise?
1250.
Yep, 1250. Remember, you are working backwards this way and then going back to whatever you need to find. The arc tangent of 50 over 12 gives you 76.504. Now, this is what I'll say. Because on your test, it's going to be different, okay? It's not going to be quite as easy-ish, depending on what's easy for you. But what do you think I want you thinking about right here at this step whenever you find the arc tangent? Because you might get a negative, you might get a positive. I want you thinking the positive one.
Because it's a real life.
Because it's a what?
Real life situation.
Because it's a reference angle. When you do this, guys, this is a reference angle that you're finding. And all reference angles are positive. So it's to the nearest x-axis, up or down, okay? But I want you looking at this vector right here because this will tell you what quadrant are you supposed to be interpreting this to be in. What quadrant is it anyway? Quadrant 1, right? So you're not going to subtract it. You're not going to take it and add it to 270 or whatever. You're going to straight up just leave it as is. And the directional angle, just like you said, is 76.504 degrees. And you'll get more practice tomorrow when you're doing the bonus point for participation. Or, sorry, the bonus point for groups.
So, just showing the chart would be a good way to display the answer.
Yes, and I would say do that. Because then everything is there. The only thing that I would say is make sure that you write in words, just like we did in class, what you're talking about. Okay? So, looking at this. Okay, so the last part is x squared plus y squared. Take the square root. What did y'all get? 420 miles per hour. Now, this is what I'll say. The swing is representing this, which is showing what I needed to do in order to make the resultant happen. Okay? So, if I said in words, what do you have to what do you have to do to make the ball go in the hole? You would say the person has to hit it. To me, this is what I'm looking for. 90 minus 76.504. Please do that in the calculator real quick. What do you get? 13.456. So 5.6, right?
Yeah.
Or 9.6? So you would say the person needs to hit it 13.496 degrees off from center toward the right, pretty much. You're going to hit it facing 13.496
Kind of using
off
the
of the
bearing
center.
degrees almost.
Not the bearing. It's not the bearing. It's just how you're interpreting the change that you're needing to do. So if I say, what is it that you need to do? You could, yes, you could say this as far as you need to hit it at a direction of 76.504. But some of you didn't understand quite what that meant. And you'll see when you get your quizzes back here in a bit. I'm wanting you to do this. And a lot of you did. A lot of you understood, and that was good. You're ending up hitting it 13.496 degrees off from center, right, to the right of center, with a magnitude of 51.420 miles per hour in order to make it into the hole.
What if you said, like, if you did that, but you said relative to the ground or something like that? Would that make it?
So in that, I don't want you to do relative to the ground because of the fact is that you're looking forward. So your relative shouldn't be toward the ground, like elevation-wise. Your relative should be straight
Oh
forward.
no, it was one of those weird, like.
That's a different kind of problem. That's not this kind of problem. We good? All right, guys. Here comes your quizzes.